For this example, we are going to find the length of the intercepted arc, and we are given a central angle, and we are given the radius. In order for us to do this problem, we need to know a formula. And the formula that we are going to be using is described best by a little diagram. So I'm going to draw a circle here. There's the center of my circle. And when they're talking about an intercepted arc, what that means is we have two radii in this problem. And then there's an angle in between those two radii that we would call theta. So from the center out to the edge, we have a radius here. We'll use the variable r for that. We have another radius there. We have this angle, which is often called a central angle, if the center of the circle is where that angle is formed. And then the intercepted arc. The intercepted arc is actually the arc or the part of the edge of the circle in between those two radii. So the radii hits here and it hits here. So the intercepted arc that they are talking about is that edge right there. That is our intercepted arc. That's that piece. So it's part of our circumference. It's a length. If we put a string there and measured that, we could straighten the string out and then measure that with like a ruler or something. The variable that they use for this intercepted arc is s. So there are three variables that are related with this idea. We have our radius, we have angle theta between the two radii, and then we have this length of this arc. So the formula that we use for this is S is equal to R times theta. To be clear, this S that's here, that is the length of that intercepted arc. Is what they call that. And we know R, that's the radius. And then theta, that is the measure of our angle. Oops, can't spell measure today. Try that again. Measure of the angle. But it is a little more specific than that because we can measure angles in a couple of different ways, in degrees and radians. In order for you to use this formula, it has to be in radians. Otherwise, the formula does not work. So here's a picture of what it is that we have. They gave us some information here. They told us that the central angle was pi over 6. That's our value for theta. And they told us the radius was 2.5 meters, and we're supposed to figure out the intercepted arc. This angle here is in degrees. I'm sorry, is in radian measure, so we can plug that into our formula. So our formula is S is equal to R times theta. We're trying to find S. The radius is 2.5, and our angle theta, which has to be in radians in order for us to use this formula, is pi over 6. We are going to take this and plug this into our calculator and then round this off. We're going to round it off to 1 decimal place. So I just want to do 2.5 times, and I'm going to do pi over 6, use the pi button for that, round that off to 1 decimal place. So the intercepted arc, the arc length there, is approximately equal to 1.3. It would be 1.3 meters because we do have meters in this problem, but you could definitely do that without the units on it, and I'm not going to be super picky about that. For letter B, we're going to do 300 degrees, and R is equal to 4 yards. So again, we want to use this formula. S is equal to R times theta. We are trying to calculate S. I can plug in the radius, that's 4, and then I want to multiply that by theta, our central angle. But the central angle does need to be in radians here, otherwise the formula doesn't work. So before I can go through and do this problem, I do need to convert this 300-degree angle into radians. How we do that is we multiply by pi radians over 180 degrees. The degree symbols here, those would cancel. And I would want to reduce the fraction. 300 1/80ths, come up with an improper fraction in its reduced form. If you do that, you end up with 5/3 as your fraction. So this is 5/3 from the 300 over 180. We also need a pi up there in the top, and that is our angle measure in radians. So now I'm ready to plug this into my formula. I need to do our radius 4 times our angle theta in radians. So I'm going to multiply that by 5 pi over 3. So we just take that and throw that into our calculator. 4 times, I'm going to do 5 times pi using my pi button divided by 3, and then round that off to 1 decimal place. And we get about 20.9 for that. So the intercepted arc on this one is approximately 20.9 yards if you were going to include your units on that.